Hi, welcome back to AT Math. Today, 7-4, Division Properties of Exponents. Remember this. If you have 5 to the third power times 5 to the first power, it becomes 5 to the fourth power because we're adding 3 5s and one more 5. And if you have 5 to the third times 5 to the first, well, there it's going to be 5 to the second because 3 plus negative 1. Well, as the 5 to the negative 1 can be written as 1 to the fifth, remember, because you have here, remember, really 5 is 5 to the first, or 5 to the first power, and a negative 1 would mean you just switch from top to bottom. In fact, to remind you, a negative exponent turns into a fraction. 5 to the negative second equals 1 over 5 squared, because we're simply flipping it. 4 to the negative third power means 1 over 4 to the third power. So anytime you see a negative, it's just 1 over. Instead of being real large, it becomes real small. It just flips positions. 2 to the negative fifth power becomes 1 over 2 to the fifth. I think you get the gist of it. Well, back to this. 5 to the third times 5 to the negative first. So again, we're adding the exponents. So 3 and negative 1 make 2. Okay. And it can look like this. 5 to the third times 1 over 5 equals 5 squared as well. Now why? Because 5 to the negative first means 1 over 5. Now, can I have 1 over 5 or 1 over 5 to the first? It really means the same thing, so don't worry about it. But what you would do is you would take 5 to the third times the 1, so this would go on top, and then you divide by 5 to the first. In other words, you're saying, okay, I got 3 5s. I'm going to take away one of the 5s, and I have 2 5s left. You see here, 5 to the third over 5 to the first equals 5 to the second, and we're going to talk about why right now. You notice that 5 to the third makes 5 times 5 times 5. Okay, and 5 to the first is just 1 5. 3 5s versus 1 5, they go ahead and fight it out. You lose a 5 from each one, and 2 5s are left. And therefore, 5 times 5 is 25. Now let's try another. 7 to the sixth power times 7 to the negative fourth power. Now basically you can go ahead and change this to 1 over 7 to the fourth power. And 7 to the sixth times 1, which is 7 to the sixth. Divide by 7 to the fourth, so you're taking 4 away. Like this. And notice how if I lined them up, I would go ahead and cancel 4 of them out, leaving 2 on the top. Now the shortcut, of course, is this. 7 to the ninth versus 7 to the fourth. Just imagine a tug of war between the 9 and the 4. The question simply is, who has more people? It looks like the top does. The top has more people with the 9 versus the 4, so the top wins by 5 more. So if you take it, think of your tug of war again, 9 versus 4, top wins by 5. So 7 to the fifth is what's left. Now I could put over 1 or just keep it as 7 to the fifth. It makes no difference. Let's see, so 7 to the fifth. Very good. Quick break. And back. More examples. 5 to the fifth over 5 to the second. 5 versus 2, top wins by 3. 9 versus 2, top wins by 7. You try. 8 to the 15th over 8 to the second power. I guess I ought to cover the you tries up. Okay, you try now, as if you didn't see it. Go ahead. Here's what the answers were. 15 versus 2 is 13. 25 versus 12 is 13. Pretty straightforward. Now what happens when you get this? When you get 8 to the 5th power over 8 to the 12? Well, now the bottom wins by 7. Since I have to put something on the top, you just put a 1. That's all you have there. You try, go ahead. Did you get these? Hope you did. Now same for a variable. X to the 4th over x squared. Top wins by 2. Ant to the 3rd power divided by ant to the 8th power. Bottom wins by 5. Try again. Shuttle capsule to the 2,247th power over 123. As you see, because I didn't guard the answer, 2,219 on the top. Quick break. And back. We will now do more than one. So I have 2 sets of numbers here. I suggest making lanes. Since they're all times anyway, I'm just going to line up. 5s with 5s, 7s with 7s, etc. So 5 versus 2, top wins by 3 for the 5s. 7s, top wins by 2. So notice that when I fight it out, this 3's left and just a generic 1, and 2's left on top, just have a generic 1. So 5 third times 7 squared. Now I would be happy with this answer here. That's good with me. If you want, the book will have 6,125. Either one's fine for this lesson here. Actually, you know what? No, I can't take that. No, I can't be happy with that answer because one of the rules we learned last time was you couldn't leave numbers exponented. So we're going to have this here. All right. You try. Go ahead. All right. Hopefully you have 2 to the 3rd on top and 5 squared on top as well. I will not be happy with that answer. I need it solved down to here. There you go. We'll do more than one variable. So go ahead and try this. Make lanes. Did you get this? X to the 3rd, y to the 2nd. Now since they're variables, all we'll do is just stack them side by side. We'll just get rid of the times and put them like that. You try. Okay. A wins on top by 2. B wins on bottom by 4. There's your answer. There's nothing more I can do here. This is it. Quick break.
Yeah.
And back. Now for this guy here, A to the 4th, B to the 6th is pretty well set up. However, the bottom has all this cubed, so you have to take both of these to the 3rd power. Excuse me. So a to the 3rd power becomes a to the 3rd. B squared cubed becomes 6. Now if you forget y, there's 3 b squareds now. B squared times b squared times b squared. So it becomes b to the 6th. Now we go ahead and compare. Well, a to the 4th over a to the 3rd, top wins by 1a. However, top and bottom tie on this. And remember, anything divided by itself is 1. So basically, these cancel in this case. You know, the times 1. Anything times 1 is itself. So they basically cancel out. Leaves a to the 4th, a to the 3rd. Top wins by 1. You try. Did you get this? First, I had to change all this into this. And this into this. And then, top wins by 10. Top wins by 16. Practice some more. Go ahead. And the hint is just multiply the 3 and 2 first. So this here, I mean. So it's 5 times 3 is 15. 8 times 3 is 24. That's obvious. And then take this, make 6. Once this becomes a 6, then C to the 6th, R to the 6th. Cross out and compare. Put in lanes. Let's see, 9 on top and 18 on the top, I believe. There you go.
There's plastic wrap on the door, and my cat's about to run through it. Go!
I made money on my thing.
Now it gets a little choppy. You can follow on page 468 to help you. And basically what we're going to do here with the scientific notation. You know, before when it was a fraction, you just flipped the back. But this really wouldn't work being flipped. Just not what you want. What you can do is you're going to take 2 divided by the 8. Well, okay. And that goes here. And then 10 to the 8th divided by 10 to the 5th. Well, 2 to the 8th will become 1/4, or 0.25, whichever way you want to do it. 10 to the 8th divided by 10 to the 5th. You stack them. Top divided by bottom. Top wins by 3. So this becomes 0.25 times 10 to the 3rd. But remember, this has to be between 1 and 9.99 or 10.0. So we got times by 10. If I times by 10, I got to take away 10 here, as shown. 2.5 times 10 to the 2nd power is your answer. Again, go ahead and try it. 8 over 2, got it. 11 divided by 3rd. 10 to the 11th divided by 10 to the 3rd, excuse me, is here. So 8 divided by 2 is 4. 10 to the 11th divided by 10 to the 3rd. 11 over 3 is 8. 4 times 10 to the 8th. This is actually okay, or you could put 4.0. Either one is dandy. Whoops. You try. Go ahead. Did you get the following? 3 divided by 12, and then 10 to the 11th divided by 10 to the 8th. 0.25 times 10 to the 3rd, but times and divide. And there you have it. Well, that looks just like the answer from before. It's crazy. Quick break. And back. Now this, when you have a fraction that's cubed, you basically just times in all 3 fractions out. So I could take 4/5 times 4/5 times 4/5. That's certainly fine. But what I'm saying is, since I'm cubing it or squaring or anything, in a parentheses to whatever power, I can just take both of these to that power. I'm saying I could take 4 to the 3rd power and 5 to the 3rd power. That's all you have to do. So 4 to the 3rd power would be 64. 5 to the 3rd power is 125. And my rule was that if they were going to be bigger than 100, you could just keep it like this. But honestly, you're AT math. Go ahead and just go ahead and solve out the numbers. That's fine. So you try. Go ahead. You get the following. So I have these here, and then I went ahead and put the exponents, and then you go ahead and solve them out. Now notice here how 64 over 16 becomes 4, 27 over 7, 29 becomes 1/27. Here's a hint. 8 over 4 can just become 2. You can just take 2 squared and make 4. And notice here 3/9 becomes 1/3. You could just take 1/3 times 1/3 times 1/3 and get 1 over 27. And this guy here, well, you work it out and you'll be fine. And I just explained here how you could pre-divide ahead of time. So 8/4 becomes 2 and 3/9 becomes 1/3. And that's just how you can do it. It's much easier. Now we're going to put the whole thing together. 3x squared cubed. We're going to cube the 3 and we're going to cube the x squared. So 3 cubed is here. X squared cubed is here. So 3 cubed is 27. X squared cubed is actually 6. A lot of you will have no problems taking x squared times 3. Sometimes, though, you'll forget to take 3 cubed. Remember, 3 is now involved because of the parentheses. If it was just this, well, it doesn't really look right. It wouldn't involve the 3, but because the parenthesis 3 is included. Another, 3x squared y cubed to the 2nd power. So what we're going to do is we're going to go ahead and take 3 squared, x squared, and y cubed squared. So 9, x to the 4th, y to the 6th. You try, go ahead. Did you get these? I hope so. Now let's put all this together. 15r cubed over 5r squared. By the way, you cannot pre-divide here because these are inside a exponent. and exponent comes before times to divide, because remember, a fraction is divide, so you have to go ahead and square first if it's like this. So 15r cubed becomes 3,375r cubed, and 5r squared becomes 25r squared. Well, you have to try to work some things out. It turns out you can divide it by 25, so that makes 135. 3r's and 4r's fight it out. Bottom one wins by 1. By the way, if you want, you could do this, and I'm not saying you have to, but 15 cubed, you could put 15 times 15 times 15, then of course r cubed. And you could put 5 times 5, and then r to the 4th. Now what I've done is I've simply went ahead and separated these numbers. Now why am I going to do that? Because I could pre-divide this and put a 3, this and this and put a 3, because 3 times 15 is 45, and 3 times 45 is 135. So I could actually do that one in my head rather than try to come up with some crazy number like 3,375. But that's completely up to you. If you want to do it this way, I have no issues with that whatsoever. Let's do another. Notice here, 8r squared and q to the 3rd all have to be squared. 5r to the 6th both have to be squared as well. So 8 times square is 64. R squared is 4. Q cubed squared is q to the 6th. 5 squared is 25. R to the 6th squared is r to the 12th. Fight it out. Can't do that with 64 and 25. They do not work into each other. The r's fight it out. Bottom wins by 8, not 6. I don't know what I was thinking there. That should be an 8. And top wins by 6 q's. So we have that there. You try it. Go ahead. Let's see. Hopefully you got the following. 2 square makes 4. D to the 2nd square makes 4. U cubed to the 2nd. U to the 6th. 5 square is 25. D cubed squares is 6. U to the 6th square is 12. Fight it out. These can't do nothing. Bottom wins by 2. Bottom wins by 6. And now, break time. Let's come back. And now finally, this whole thing is being parentheses. Now this time, because the whole thing is being parentheses, it's saying we want to square everything. So you can go ahead and take 2 squared, d squared, u square, square, square. Everything gets times by itself. You can do that. Then you solve it out. 4 over 25. This becomes the 2 in the bottom. This becomes the 6 in the bottom. But you can pre-divide. In other words, since all this is contained now and the squares on the outside, you can do the stuff inside the parentheses first. So we can go ahead and take 2d's versus 3d's and put the 1d on the bottom, and take 3u's versus 6u's and put the 3u's on the bottom. So it looks like this when we're done. Much easier to manage. I square this now and I get my finished answer either way. To be honest, I don't care if you do it this way first and work it out, or you want to pre-divide and work it out. Completely your call. Now there are times when you cannot pre-divide or reduce after. Take a look at this. 2x cubed over yz, and all this is cubed. Well, you have to get everything to the 3rd power. 2 to the 3rd power is 8, x to the 3rd power to the 3rd power is 9, y to the 3rd power is y to the 3rd, z to the 3rd power is z to the 3rd. Okay, and that's where we're at. There's nothing I can do with it. You try, go ahead. Did you get this? Here's what I had, everything to the fourth power, blam. And that's your answer. There's nothing more I can do. Now remember, x to the negative first power equals 1 over x. Because we switched. Remember, instead of x over 1, it's 1 over x. Well, we're going to do it again. But in this time, instead of 2 over 3, 3 over 2. So pretty straightforward. So with the fraction, you just switch the numerator and denominator. So here, negative 4/5 becomes 5/4, and then 7/8. But to the negative second power, well, first thing you do is 7 to the 8th, make it 8 to the 7th, and then go ahead and square them, as it says. Then it becomes 64 over 49. And I'm not going to expect you to make 1 and I think it's 15 over 49. Nope, this will be fine. You try. Go ahead. Flip. Cube. I'm predicting 27 over 8, which I went ahead and made 3 3/8. You can combine as well. So 2 to the 4th, 3 squared, negative second. First, flip, flipped. Now square them. 3 squared, squared, 3 to the 4th. 2 to the 4th square is 2 to the 8th. And let's see here. 3 to the 4th is, oh, that's 81, I believe. And 2 to the 8th, well, let's see. 2 times 2 times 2 times 2 is 16. 2 times 2 times 2 times 2 is 16. 16 times 16 is, I better work it out over here. I know 15 times 15 is 225. But it's 256, but we'll see. 6 times 6 is 36. 3. 6 times 1 is 1. 6 plus 3 is 9. Carry the 0. 1 times 6 is 6. 1 times 6 is 6. 1 times 1 is 1. Sure enough, 256. So 81 over 256. Same with this. X squared over y to the 4th. First we flip. So y to the 4th over x squared to the 5th power. So 4 times 5 and 2 times 5. Done. You try. Go ahead. X to the 7th over y to the 9th. All over to the negative 5th. Did you get this? Flip first. Times the 5th power. Good to go. Now this. Wow. Well, what we're going to do here is I'm going to split it up. Just separate for now. This is going to get flipped, then squared. This is going to get flipped. So I go ahead and do all that. I go ahead and flip this and this, times them all, not times them, square them all. So 3 times 3, y to the 9th, y to the 9th, 2 times 2, x to the 5th times x to the 5th. Now use times across. 9 times 5, y to the 18th, y to the 9th combined to y to the 27th. 4 times 4 is 16, x to the 10th, x to the 7th is x to the 17th.
Tell me the duck story.
Bum, 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 ba-dum, ba-dum. A duck walked up to a lemonade stand, and he said to the man, run in the stand, hey, bum, 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 got any grapes? The man said, no, we just sell lemonade, but it's cold and it's fresh and it's all homemade. Can I get you a glass? The duck said, I'll pass. Then he waddled away, waddle, waddle, till the very next day, bum, 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 ba-dum. When the duck walked up to the lemonade stand, and he said to the man, run in the stand, hey, bum, 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 got any grapes? The man said, no, like I said yesterday, we just sell lemonade, okay? Why not give it a try? The duck said, goodbye. Then he waddled away, waddle, waddle. Then he waddled away, waddle, waddle. Then he waddled away, waddle, waddle. Till the very next day, bum, 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 ba-dum. When the duck walked up to the lemonade stand, and he said to the man, run in the stand, hey, bum, 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 got any grapes? The man said, look, this is getting old. I mean, lemonade's all we've ever sold. Why not give it a go? The duck said, how about no? Then he waddled away, waddle, waddle. Then he waddled away, waddle, waddle, waddle. Then he waddled away, waddle, waddle. Till the very next day, bum, 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 ba-dum. When the duck walked up to the lemonade stand, and he said to the man, run in the stand, hey, bum, 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 got any grapes? The man said, "That's it. If you don't stay away, Duck, I'll glue you to a tree and leave you there all day stuck. So don't get too close." The duck said, "Adios." Then he waddled away, waddle, waddle. Then he waddled away, waddle, waddle, waddle. Then he waddled away, waddle, waddle. Till the very next day, bum, 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 ba-dum. When the duck walked up to the lemonade stand, and he said to the man, "Run in the stand. Hey, bum, bum, bum. Got any glue?" "What? Got any glue? No, why would I? Oh, then one more question for you. Got any grapes?" Bum, 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 bum. And the man just stopped. Then he started to smile. He started to laugh. He laughed for a while. He said, "Come on, Duck, let's walk to the store. I'll buy you some grapes, so you won't have to ask anymore." So they walked to the store, and the man bought some grapes. He gave one to the duck, and the duck said, "No thanks. But you know what sounds good? It would make my day. Do you think this store? Do you think this store? Do you think this store has any lemonade?"